At the end of 2021, the James Webb Space Telescope, launched aboard an Ariane 5 rocket from the Guiana Space Center in Kourou, French Guiana, reached its designated Lagrange point and entered a preparation phase lasting over 6 months. After aligning its mirrors and calibrating its instruments, the telescope began its scientific observations on July 11, 2022. One of its first tasks was to capture a deep field image of the galaxy cluster SMACS 0723, located 4 billion light-years from Earth. The image, obtained using Webb's near-infrared camera, NIRCam, after a 12.5-hour exposure, became a major event in the astronomy community. Even in its first images, James Webb revealed that the universe might be much older, larger, and more spectacular than we had thought. Welcome aboard the Spaceship Earth. In this video, we will talk about the new cosmic mysteries uncovered by the James Webb Space Telescope, an instrument that, since beginning operations, has made countless observations of the depths of space, from star-forming nebulae to the earliest galaxies in the universe, reshaping what we know about the cosmos after the Big Bang. Designed to make the invisible visible, the James Webb Space Telescope was first planned in 1996, and construction began in 2004, with the goal of observing epochs of the universe that could be considered its infancy. Over the 25 years from planning to launch, this project pushed the limits of patience and technology, revealing that some of what we thought we knew was wrong, and that there are countless phenomena we had never known existed. During its observations, Webb detected some of the first galaxies to form in the universe. These galaxies, formed 13.5 billion years ago, did not align with previous theories and predictions about galaxy formation. Astronomers had believed that galaxies began forming 400 to 500 million years after the Big Bang. However, Webb discovered the galaxy Glass Z13, which formed only 300 million years after the Big Bang, proving that this assumption was wrong. This finding showed that matter in the early universe condensed into stars and galaxies much faster than previously thought, and that complex structures like galaxies could already exist in the universe's earliest eras. Thanks to its cameras, James Webb also revealed how stars are born. Stars begin inside massive clouds of gas and dust. A good example is the Pillars of Creation in the Eagle Nebula, a region of interstellar gas and dust. In the past, even powerful telescopes like Hubble could not reveal the details inside these dust clouds because visible light was blocked. Webb's ability to observe in the infrared spectrum allows it to see through the dust, making it possible to study the earliest stages of star formation in far greater detail. The same capability also allows us to study the first stages of planet formation. The dusty disks around young stars gradually clump together to form planets. Since this process happens within dense dust, telescopes operating in visible light struggle to capture it. Using Webb's infrared cameras, astronomers can study these protoplanetary disks and clearly identify dense regions where planets are beginning to form. Observations have revealed that the cores of forming planets contain water, carbon compounds, and complex molecules, essential ingredients for life. Detecting these materials at such an early stage offers important clues about how life might emerge in the universe. Webb identifies the presence of carbon or complex molecules in stellar disks using its near-spec spectrometer. This instrument passes the light from an observed region through prisms to create a spectrum, which is then compared with reference measurements for known substances to determine the dust cloud's chemical composition. Using this same method, Webb also searches for signs of life on other planets. By studying the atmospheres of exoplanets, planets beyond our solar system, James Webb can determine their chemical makeup. This enables scientists to check whether they contain the essential building blocks for life or even potential signs of life itself. For example, in the atmosphere of the giant gas planet WASP 96b, Webb detected water vapor. While this alone doesn't prove life exists there, such observations increase the possibility that life could be far more common in the universe than previously believed. Since it began operations, the James Webb Space Telescope has raised more questions in astronomy than it has answered. Scientists have now seen that galaxies and black holes formed much earlier than expected. Because this information does not fit with many existing theories, new hypotheses are being proposed and simulations of alternative early universe scenarios are being developed. Webb has also clearly observed hydrogen gas filaments connecting galaxies. These structures, predicted by theory and simulations, have now been confirmed to exist. This discovery shows that galaxies are not entirely isolated, but were once part of a cosmic web of filaments binding the early universe together. Working almost non-stop to fulfill astronomers' requests, Webb collects around 20 terabytes of data each year, much of which has not yet been fully processed. Even the small portion that has been analyzed has significantly changed our view of the cosmos. Some of this data has been made public, allowing space enthusiasts outside the academic community to explore it and contribute new insights from different perspectives. James Webb has taken up the torch lit by the Hubble Space Telescope, carrying humanity's excitement for space exploration even further. Expected to operate for at least 10 and possibly 20 years, Webb will eventually be succeeded by a new generation of telescopes. Advances in space transportation, with rockets like Vulcan, New Glenn, and Starship, will enable the launch of much larger and more capable observatories, thanks to increased payload capacity and volume. Although it is still unknown which telescope will replace Webb, several important candidates already exist. One such planned observatory is LUVOIR, expected to have a 15-meter mirror and projected to begin operations in the 2040s. Another NASA project, HabEx, will focus on finding habitable exoplanets. It will feature a system designed to block starlight, making it easier to detect Earth-like worlds, and is expected to make significant contributions to exoplanet research. Another candidate for the 2040s is the Origin Space Telescope, OST. Like Webb, OST will observe in the infrared spectrum, but it will be 100 times more sensitive, enabling it to detect even the faintest and smallest galaxies. Thousands of years ago, humans looked up at the sky and wondered about the bright lights they saw, some fixed, some wandering. From those early questions to today's James Webb Space Telescope, humanity has developed and used countless tools to find answers. Our curiosity to understand what we see and to discover what lies beyond will ensure that we continue learning more about the universe every day. So never stop being curious and exploring. Thank you for watching Spaceship Earth. If you found this video useful, please like and share it. You can support our channel by clicking the thanks button or joining as a member. Subscribe to avoid missing our future videos about space and space technology.